Okay, hello my students. We are working on the experiment number 3 for this MECH410 laboratory class. We have already done experiment 1 and 2, and today's experiment talks about reverse engineering. And even before today's class, I have shared the introduction to reverse engineering. As the name suggests, it is something you do in a reverse order. Most of the time you go to SolidWorks, design a part, convert it to STL and make a prototype for 3D printing. This time you cannot go to SolidWorks. I'm going to give you a simple part like American football, and you don't have any dimensions or data on the computer. You need to use this reverse engineering system that Loyola Marymount University procured several years ago. I was a professor in charge of development of this reverse engineering, and we have a very low cost reverse engineering system we call like a next engine scanner. They are housed in Santa Monica. It costs only $3,000, but it helps us recreate an object using reverse engineering. So our goal here is to product development using a low-cost reverse engineering system. So as I always talk about what we are going to do in this experiment. So as I said, our goal is to recreate a football through reverse engineering in 3D printing. So this is the American football or something looks like American football that I have, and I'm going to give it to you. You need to use my low-cost system to recreate another football that looks like this, and then compare the dimensional accuracy of that one versus this one. Okay, why we are doing it? Because we know that reverse engineering reproduces surface geometry in 3 dimensions on a CAD system, and also it is necessary because for many physical systems there is no data available to us. Think about some artifacts that were discovered in Egypt 10,000 years ago, and if you have to recreate that, you have to use reverse engineering. So reverse engineering is extremely useful for many applications. So how we are going to do it? It's very simple. As I said before, I have procured a small next engine scanner. This is the scanner. It looks like this, very small, you'll see in the lab. And the scanner is connected to a holder. This is a stand on which I'm going to put that football, as you see over here. And so all you need is basically the scanner and the holder. And then later I have to have a computer with the software that runs this scanner. And it's all installed for your use. So basically, we're going to go through 5-6 steps of recreating this reverse engineering football. So first thing, step 1, make this system ready. We'll give you a demonstration, especially our lab manager will show you how to turn on the scanner, how to go to a computer, bring the software. Once everything is ready, you put the football on the holder and start scanning. Normally what we do, the principle is that this scanner, we create the surface geometry. We try to rotate it 5 times. Each time it rotates, the scanner scans 1/5 of the section, and then it goes to the 2nd, 3rd, 4th. After 5 sections, it has completed 360, and then we put them together. So the first step is to recreate the outer surfaces, and once you have done that, then we scan the top of the football and the bottom, and we stitch the top and bottom to the previous scanned objects, and it becomes a complete American football. Once we have created the football in the software, we create a CAD file from the surface data. Once we create the CAD file, most of the problem is done because that CAD file can be converted to STL file, and STL file means you can go to 3D printing, and once the STL file is created, we'll go to 3D printer and recreate. And so basically this is the original American football, and if we can do this successfully, we have done it few times, then this is your reverse engineered American football. It should look like very similar, so if you can recreate and print me this reverse engineered object, the experiment is done. So we are talking about the 5 steps, and the last step is to measure the accuracy, because okay, you have reverse engineered this object. How good is this one compared to the original? Because sometimes if the dimensions are not very good or the surface roughness is not very good, so we always have to do some evaluations. We can do evaluations based on dimensional accuracy or the surface roughness. We have a surface roughness profilometer that we have used in DOE experiment. So right now you complete the procedure. So what is the result? In this one, the result is very simple. You have the original football and you have the reverse engineer. So I want you to put these two pictures side by side in the results section. And also the last section is the dimensional accuracy. You should come up with a table, one, where you show that this is the XY dimensions of the original football. You can take the length of this thing or the diameter of this thing and couple of places. You do the corresponding measurements on your reverse engineer, say how accurate this one is, it within 1 to 2% of the original. Once you do that, then you go back and complete your report, and we will be able to complete this experiment number 3. Thank you again. We'll see you and talk to you later. Stay safe.